Right. Good afternoon. So my name is Jannis, and they are presenting SwissBERT, the multilingual language model for Switzerland. And this is joint work with Johannes, this is back, and Sennrich. So in the past few years, third-style models have become a really useful tool for natural language processing. And people have also started creating specialized or customized versions of BERT. So, for example, there is the common BERT model that has been trained on French language, or there are domain-specific models, for example, for the legal domain. Now, today we're adding another model to the list, and this is SwissBERT. And so, because Switzerland is a multilingual country, SwissBERT is also multilingual model. So it's a encoder that supports all national languages in Switzerland: German, French, Italian, and indeed Romansh. And we've trained SwissBERT on news articles only. We use 21 million news articles in Switzerland. Now, because we only use news articles as training data, SwissBERT optimized for this specific domain, so I wouldn't recommend to use it for processing dialects and Swiss German. But our expectation is that it's really useful if you want to process news articles as well as So we retrieved the 21 million news articles from SwissDocs and Graën. And this is a service provided by the linguistic research infrastructure of the University of Zurich. And it's a platform that makes news articles in Switzerland available to researchers in real time. And we used articles from different publications in 4 languages. And as you can see, there are many publications for German, French, but there are only 1 publication for Italian and Romansh each. And as you know, in machine learning, this is a really challenging problem. How can you balance the training process if you have such imbalanced data? In this case, how can you make sure that SwissBERT learns about Romansh, even though you just have 33,000 articles, orders of magnitude less than you have for the higher resource languages. Now, the approach that we use are language adapters. And we use the method described in a paper by Python and others. Language adapters are language-specific model components that you can add into the formal layer. So in each formal layer, you have a bottleneck layer for language 1, language 2, all the way to language n. And if you have an input in a language, you would then only activate one of those adapters. And the advantage of language adapters is that you have a reserved capacity for every language, independent of the amount of training data that you have. And so the idea of language adapters has existed before, but what Python and others did is they trained a large encoder model from scratch with language adapters. This model is called XMod, and it comes with language adapters for 81 different languages, including German, French, and Italian, but not Romansh. So what we did is we created SwissBERT by adapting the XMod model using our corpus. And we trained 4 adapters for the 4 national languages, including adding a totally new adapter for Romansh. We also created a new byte vocabulary. We needed to do this because we wanted to include Romansh words, of course. We also wanted to include names and words that are common in Switzerland. And we also trained a new word embedding layer that goes with this. So all the purple parts are the ones that we created during the adaptation phase. The rest of the model remained frozen. So this was an experiment. We weren't sure whether it's really going to work. So we made sure to have a careful evaluation to see whether the adaptation actually had an effect. Our main task was named entity recognition, and our expectation was that if you perform any R on news articles, then SwissBERT should be more accurate than the baseline models that have not been adapted. I'm also going to show you a few other selected results. So the identity recognition is the task of identifying and classifying names in text documents, person names, location names, organization names, miscellaneous entities. And in order to evaluate SwissBERT, we created a custom test set called SwissNER. We took 400 paragraphs for each of the 4 languages and annotated them in text. We then fine-tuned the models on a generic NER training set and evaluated the fine-tuned model on SwissNER. And we found that SwissBERT has higher accuracy in this domain than the other models that have not been adapted to platforms. Now, what's interesting is that this also holds for Romansh. So we didn't train SwissBERT on NER in Romansh, so the zero-shot transfer. And still, SwissBERT had a stark increase in accuracy. But not all results were positive. We all had negative results when we evaluated SwissBERT on NER historical news from Switzerland. So it is a much more challenging task because you have many OCR errors. And we did find that SwissBERT can improve over the XMOD model that's not adapted. But we also evaluated the Europeana models that have been trained on historical news. And those are more accurate than one that has only been trained on contemporary in the last few decades. So here the recommendation is that if you want to process historical news, especially if you have OCR errors, then it makes sense to check out these specialized. So the last result I wanted to show you is German Romansh alignment, sentence alignment. So if this sounds familiar to you, it's because has just presented this task in the last presentation. And as you've heard, he created an annotated dataset of 600 German sentences and the Romansh translations. He annotated the word alignment. So basically, we followed his evaluation procedure and evaluated SwissBERT, and it performed an unsupervised word alignment. And we found that, again, there's a clear improvement over the models like XLMR, also MBERT, that have not been trained on those 33,000 articles. We also looked into sentence alignment. I think this is a question asked by Autumn. So sentence alignment means that for every German sentence, the model needs to identify the corresponding Romansh sentence in the corpus using an unsupervised similarity method. In our case, we use both score as similarity. And here we were especially surprised that SwissBERT can solve this task with almost 100% accuracy, which is remarkable because we only had 33,000 Romansh articles. So these are the only examples of Romansh that the model has seen. So for this reason, I wanted to raise the question, why did the application work so well, especially with respect to Romansh? And so as a matter of fact, I cannot give you a definite answer because we did not perform any ablation experiment that allowed us to say this factor that makes it possible. But what I can tell you is that one advantage is that we used XMOD, which is a language model that has been designed for adaptation to the language patterns in the first place. We also had were fortunate to use a large high-quality corpus from SwissDocs period. We didn't have to crawl the web, and it was contributed to the successful adaptation. And finally, so those news articles, they are not totally random. So the articles in the different languages, they cover similar events, similar topics. So it makes sense that the model can also make those crossing alignments using the database. Right, so that's it. So I encourage you to check out our model. The weights are openly available on the Hugging Face Model Hub, with one caveat: so the model is currently published under a non-commercial license. So you're free to use it for academic research, but you could not use it right now for commercial product. Okay, so let me summarize the presentation. We released a multilingual language model for Switzerland, which includes 4 language adapters for the 4 national languages of Switzerland. We also evaluated the model on Switzerland-related language understanding tasks and found that it performs better than the non-adaptive models, especially on Roman. Thank you.
Plenty of time for questions. I would like to start with the question. I start by asking a simple questioning. If the model, you want to use the model on text, unseen text, you first have to decide which language are you confronting. So you know that pick the correct answer. And this is one aspect of the problem. And second, the selection of the adapter, how does technically work? Is it the parameter that you can give input?
Right, so the question is, how do you select the adapter that should be used at the given inference step? And this is the point where adapters are not really elegant from language identification. And depending on the result of this identification, you would then activate one adapter and the
There is no way to get it directly from the architecture itself. Running in parallel with different adapters and see which one is performing better. Yes, language.
Absolutely. So this is an ongoing research area. People have experimented with really using a linear combination of adapters, making this a little bit less discrete. But yeah, so research on adapters is ongoing, and we will see more elegant solutions.
And when it's correctly, all the parameters of the network except the adapter may have the same. We don't change anything. Right? All
I have a question related to that. I think in the next slide, this question exactly, you did say that you actually changed the vocabulary of the embedding, and how can you make sure that the embeddings align with the original ones, so that it doesn't place
yes.
You don't change the way.
So let me motivate why we're training embeddings. The reason is that we had 21 million news outputs. I mean, that's a lot. It's actually 4 times as much as the original BERT model was trained on with the corpus. And if we just fine-tuned the adapters and kept everything else frozen, we wouldn't have offered the model enough capacity to actually learn something from our corpus. So this is why we trained a new embedding layer. And you also asked, how did we make sure that the embeddings align with you? First of all, I would say that this can be learned end-to-end. So the model theory could learn to use word embeddings that are compatible to the rest of the transformer. But we help the model by initializing the embeddings in a way that it's easy to do this. So what we did is, and this is a common technique, didn't invent this, the technique is to initialize all the embeddings for words that are already in the original vocabulary, the original embeddings. We also had many words that were not present in the original vocabulary. Those we initialized randomly.
How many percent of those two?
I actually do have a slide for this. What this table shows is the XMOD model and the SwissBERT model. And in this presentation, I only told you about the one with the real vocabulary. So that's the line at the bottom. And as you can see, the total number of parameters is 150 million. And we trained about half of those, so 67 million parameters.
So the largest part of the text abstract already did that.
A considerable part is actually in the embeddings. And yes, so 28 million, about fifth of the total that was are in the.
Do you have an idea of the energy cost associated with training a model?
Yeah, that's a really good question. I actually discussed this extensively with my PhD supervisor, Rico, because I was worried. So I trained the model at a time when there was an energy shortage. This, well, and I didn't want to be good. So I did estimate the energy use and also the CO2 emissions. And I was really surprised to see that the total amount of carbon emitted by training SwissBERT was 1 kilogram of CO2 equivalents, which corresponds to a kilogram of bananas. But the reason for that is that the University of Zurich compensates all energy. Otherwise, I think that it would be.
And also the range of training that by model.
Absolutely, yeah. So just training an adapter is much more energy efficient. So it's more additional resources than training. So, if you have limited resources and want to adapt a large language model to your purposes, I think our work contributes general findings that have that adapters are available.
Did you see, or do you know, or remember the XLMR pre-training data distribution across these 4 languages and the performance of?
No, I didn't have a look at the original data balance. So do you have a suspicion what happened with
I don't know what the training data. I would suspect. Yeah, maybe that. I would guess Romansh has probably 0 in XLMR. Yeah, probably. The different languages, they.
Yeah, I actually can't say that because so we do have NER results for the 4 languages, but of course those test sets they might have. So one version of, for example, the French test that might be a bit more challenging than the Italian one. So I can't say.
Going to the mic,
Because in the years like Romansh has performance, French has this data, and you have 0 shot starting with your point to this. So maybe it's also this they are used for calculation. Maybe there was some false positive for Romansh. So you hand check it or the another stuff. I would look at why is Romansh so high.
Yeah, that's a good point. So one reason might be that the test set is intrinsically easier. This, for example, contains more location names, which are maybe easy to detect because they are preceded by position. So you're absolutely right. There should be qualitative analysis within fluid yet, but there's a
Actually, I just have a question related to that. That means also in this look, it's hard to find Romansh speakers. How did you build this NDR test set? Did you study this? Once you speak German and Italian and French, not too hard, or did you actually find Romansh?
Yeah, so EL expressed really gracefully that he's not a Romansh speaker. I did the annotation. I'm also not a Romansh speaker. I did have another tool that I could use, and that's the translation engine by text shuffle. So I was able to translate the Romansh articles into English or German and to double check that I really identified all of them.
So do you like? I mean, playing direction. So if you listen, all this and all,
I would say it's unlikely. So you're absolutely right that this is a limitation of our work, that we did not have a Romansh speaker as an annotator. But I would say it's unlikely that I make many annotation errors that systematically requires those.
How many sentences?
400 paragraphs per language.
Can to extend this one to other parts of the apply to the language recognition part, consider doing other parts, evaluation of can plan development.
Yeah, so as you know, bird-style models are really versatile, so there are probably hundreds of ideas how you can use them for us. And I'm also confident that they will remain useful in the future, even as those large channels. Just because they're so efficient and because you can easily fine-tune them on a task you have to place. So I can imagine that SwissBERT, even though it's an experiment, it will have practical applications. For example, I could imagine that political scientists or linguists would automatically annotate news articles and perform classification, also improve search interfaces. So there are many situations where news articles are being used in practice, and in all of those cases, I think this is very useful.
Even the code was too much directly back to pitch and Graën that funny better interest Roman being good. Any other question? I have another one about the tokenization. Obviously, your group is very familiar with this problem. So is it the same tokenization algorithm being used across the four languages? So the four languages share the same base code. Is there any problem with that? That might be one language over one.
Yeah, that's a good question. So we use the same procedure that was used for Excellent for example. So we just threw all the training data together into a file and then trained a byte-pair encoding model. We did follow previous work and upweighted the algorithm languages. So,
just weight, upweight, and Romansh, in order to get the same proportion.
Not exactly the same proportions, but they are a little bit more uniform than actually.
I was wondering if you are also planning to train it on different types of text than newspaper, contemporary newspaper.
Yeah, so I think this language adaptive approach is really versatile. We could also use it to, for example, from a adapt the model to a certain language variety or certain domain. In this case, for this experiment, we want to have a team call new and that we knew to be of high quality. Personally, I don't think so, but so the model is open source, and I encourage everyone to play with it, fine-tune it.
One question? Final question? Yeah, good, ready.
Thank you very much for your presentation. Of course, I fully agree that there are very many other applications. So with BERT model, for example, BERT topic is could one use the SwissBERT as it is for BERT topic, or does it have to do important applications?
Yeah, so it's a truism that you cannot use a master language model directly for a topic. However, there are now unsupervised fine-tuning objectives, that use fast learning to fine-tune the master language model in a way that it produces useful document embeddings. So this is definitely future work that could be really useful with fine-tuning SwissBERT.
You trained for 10 epochs, I've seen. I've seen that I'm a bit surprised that you said the corpus is so large, but did you manage to train for 10 epochs using only 8 small or relatively small GPUs by today's standard? Could you elaborate a bit more on that?
Well, it took us more than a week to do it. I think this is also, yeah, it is. So it's 18 hours per epoch, and I think one reason why we were able to fit the training process on just 8 GPUs was that we froze half of the model and we only trained the language adapters. So again, this is evidence that using language adapters for adaptation is a more efficient approach than trying to adapt the full model.
Right, I think we have time to close. Thanks a lot, Jannis. Like the presentation.